and welcome sa Mataglish. Kung bago ka lang sa aking channel, ako si Ben Paul de la Cruz at layunin ko matulungan ang mga Pilipinong mag-aaral na mas maintindihan ang math. And for today, ang pag-uusapan natin ay ang chain rule para sa mga functions of several variables. Recall natin yung chain rule dati para sa functions of single variable. If y equals f of x and x equals g of t, then yung derivative ni y with respect to t ay equal lang sa derivative ng y with respect sa x times derivative ng x with respect to t. Provided, syempre, si y ay differentiable function ni x and si x ay differentiable function ni t. As with many topics in multivariable calculus, maraming iba't ibang formulas for chain rule depending upon the number of variables that we're dealing with. So, sisimulan natin tong discussion with two very simple cases. Then, i-generalize natin to para makita niyo yung idea. So, first case tayo. Let z be a differentiable function of x and y, where x equals f of t and y equals g of t, such that the partial derivatives exist. Then, c is a function of t, and its derivative is given by partial derivative ni z with respect to x, times derivative ng x with respect to t, plus partial derivative ni z with respect to y times derivative ni y with respect to t. So, medyo mahaba tignan, pero kung titignan natin mabuti, so dito ay zz, dito yung dalawang variables natin, x and y, and then dito x and y din, tapos yung dito yung variable na meron tayo dito, so with respect to t, with respect to t. Okay? So, yung difference itong dalawang terms, ay yung ditong variable. Dito ay x, dito ay y. Okay, so mamaya mas haba yan, pero makikita nyo naman yung pattern, so hindi siya nakakatakot. So example number 1, let z be equal sa 2xy squared plus y times e to the x. Yung x ay equal sa t squared, yung y equal sa ln t. Solve for derivative ni z with respect kay t. So ito yung formula natin, no, yung kanina. So, now, solve muna natin yung partial derivative ni z with respect kay x. So, partial na to with respect kay x, treat natin na constant yung y. So, we have 2y squared plus y times e to the x. Itong y times e to the x, ito naman yung partial derivative ng second term, no? With respect sa x. So, with respect sa x, itong y constant, so copy lang yon. Partial derivative nito ay ito pa din. Next ay kukunin natin derivative ni x with respect kay t. So we have 2t. And then plus partial derivative ni z with respect kay y. So partial derivative nito with respect kay y. Treated si x na constant. So copy lang yung 2x. So meron tayong 2y. So we have 4xy. And then dito, treated na constant si x. So yung e to the x ay constant lang. So, e to the x yung partial derivative. Okay? And then, after nyan ay derivative ni y with respect kay t. So, derivative ng y with respect kay t, we have 1 over t. So, substitute lang natin yung mga values ng x at saka ng y, si t squared at saka si ln t respectively. We have this one. So, pure substitution lang yan. Palitan yung y, palitan yung y, palitan yung x, and so on. So, ganyan lang yan. Isang alternative na method sa pag-solve ng derivative ng z with respect kay t ay i-substitute muna yung t squared at yung ln t sa x and y respectively. However, hindi natin ginawa yun at hindi ko nire-recommend na gawin nyo dito kasi pag ang tinetest ay yung knowledge nyo sa chain rule, hindi natin pwede gamitin yan. Okay? So, may mga cases na mas madali pag yun yung ginawa, pero maraming cases na mas madali kapag in-apply natin yung chain rule instead na mag-substitute agad tayo. Okay? Now, punta tayo sa ating second case. Let z be a differentiable function of x and y, where x equals f of st and y equals g of st, such that the partial derivatives exist. Then, z is a function of s and t, and its partial derivatives are given by these two. So, kanina isang partial derivative lang meron tayo na with respect kay t. Pero dito, merong with respect kay s at saka with respect kay t. Bakit? Kasi si x ay function ni s and t, si y ay function ni s and t. Pero kung titignan nyo yung formula nito sa kanina, very similar, no? So, z dito, z din dito, z dito, dito s, 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 tapos dito lang magkakatalo, no? Dito yung x, dito yung y. Dito x, dito y, pero dito with respect kay t naman, so with respect kay t, with respect kay t. Okay? So, apply natin to sa ating second example. Let z be equal sa y cosine x. Si x ay equal sa st plus t squared. Si y equal sa square root ng s squared plus t squared. Solve for partial derivative ni z with respect kay s and partial derivative ni z with respect kay t. So, simulan natin to sa partial derivative ni z with respect kay s. Ito yung formula kanina. So, solve muna natin partial derivative ni z with respect kay x. So, treated si y na constant, so copy lang yan. Derivative ng cosine x, we have negative sine x. So, we have negative y sine x. Partial derivative ni x with respect kay s. So, ito si x. So, partial nito with respect kay s. Treated si t na constant, so dito mag-0. So, dito we have t. No? Ayan, so, t lang to. Plus partial derivative ni z with respect kay y. So, yung cosine x dito ay magiging constant. So, cosine x lang yung partial derivative ni z with respect kay y. And then, partial derivative ni y with respect kay s. So, ito si y. So, meron tayong square root dito, no? So, we have 1 over 2, and then square root ng s squared plus t squared. But by chain rule, partial derivative pa ng loob with respect kay s. So, we have 2s. Okay? So, ito na yung partial derivative ni z with respect kay s. So, yung last step dito, sa substitute lang natin, no? Yung y natin ay square root ng s squared plus t squared. So, papalitan natin yon. Yung x natin ay st plus t squared. Palitan lang rin natin yan. So, ganun din dito. And dito matatapos yung partial derivative ni z with respect kay s. So, punta tayo sa partial derivative ni z with respect kay t. So, very similar formula. Dito nga lang ay t na, no, instead of s. So, partial derivative ni z with respect kay x, na-solve na natin to kanina. Ito ay negative y sin x. Partial derivative ni x with respect kay t, so treated na constant si s. We have s plus 2t. And then plus yung partial derivative ng z with respect sa y. So, we have cosine x. And then, times partial derivative ni y with respect kay t. So, ito ulit yung square root natin. So, we have 1 over 2 squared na s squared plus t squared times partial derivative ng loob with respect sa t. So, we have 2t here. So, substitute lang natin yung mga to sa x and y. We have this one. Okay? So, again, pure substitution lang to. No? Huwag kayong matakot dyan. And reminder ulit, huwag kayong mag-substitute agad pag ang tinetest sa inyo ay chain rule, no? So, dito nagtatapos ang example number 2 natin. Now, i-generalize natin yung chain rule for multivariate functions. Let z be a differentiable function of n variables x sub 1, x sub 2, up to x sub n, and each of these variables are functions of m variables, say si t sub 1, t sub 2, at saka hanggang kay t sub m. Then, for any variable t sub I, where si I nagre-range from 1 to m, we have partial derivative ng z with respect kay t sub I equal lamang dito. So, partial ng z with respect sa x sub 1 times partial ni x sub 1 with respect sa t sub I plus and so on up to partial ni z with respect sa x sub n times partial ni x sub n with respect sa t sub I. Yung number ng terms nito ay equal sa number ng n variables natin, no? Now, with respect sa dami ng partial derivatives ni z with respect sa mga t, we have m of them. So, partial ni z with respect sa t sub 1, meron tayong ganyan. Partial ni z with respect sa t sub 2, and so on. So, we have m of these partial derivatives. Scary tignan yung general na form, pero okay matakot kasi hindi naman yan ine-expect na kabisaduhin nyo dahil may mas madaling paraan para makonstruct natin yung formula for chain rule kahit na hindi pare-parehas na functions of m variables yung n variables natin. Ito ay yung paggamit ng tree diagram. So, balikan natin yung dalawang cases natin kanina. So yung first case, ito yung formula. So construct natin si z ay functions ng dalawang variables, si x and y. Si x ay function ni t, si y ay function ni t. Itong orange paths ay nagre-represent ng partial derivatives or derivatives. Depende kung ilang path yung meron, no? So, dito kay z, may dalawang path. Yung isa papunta kay x, yung isa papunta kay y. Kaya partial derivatives yung mga meron tayo. Partial ni z with respect kay x, itong path na to. Partial ni z with respect kay y, itong path na to. From x, isa lang naman yung path, no? Papunta lang kay t. Ganon din kay y, papunta kay t. So, hindi na partial yung mga nandito. So, derivative ni x with respect kay t, derivative ni y with respect kay t. For derivative of z with respect kay t, kukunin natin yung sum ng mga products ng derivatives or partial derivatives na nasa path from z to t. So, product nito plus product nito. So, we have partial derivative ni z with respect kay x times derivative ni x with respect kay t plus partial derivative ni z with respect kay y times derivative ni y with respect kay t. So, kaya nabuo ito, no? So, itong pink na path, ito lang yon. Yung green na path, ito lang yan. No? So, punta natin yung second case. So, ito yung formula kanina. And meron tayong z doon na function ni x and y. Si x ay function ni s and t. Si y ay function din ni s and t. So, now, labelan natin yung mga paths. Ito yung partial derivative ni z with respect kay x, partial derivative ni x with respect kay s, and so on. No? So, pag na-construct nyo na yan, pwede na natin i-construct yung formula for the partial derivative ni z with respect kay s. Paano natin gagawin yon? So, kukunin natin yung mga paths from z to s. And we have two. Itong pink one and yung green one. So, sabi kanina, mumultiply natin itong mga pink, no? So, yung partial ni z with respect to x at saka yung partial ni x with respect to s plus itong another path, itong green. So, partial derivative ni z with respect to y times partial derivative ni y with respect sa s. So, ganun na i-construct yung formula for partial derivatives. So, how about yung partial derivative naman ni z with respect to t? So, very similar. Ang kukunin naman natin na paths ay yung from z to t. So, ito yung unang path, yung pink. So, partial derivative ni z with respect to x times partial derivative ni x with respect to t plus yung sa green na path, partial derivative ni z with respect to y times partial derivative ni y with respect to t. So, ito na yan. So, now, ang pinakita ko lang ay yung dalawang cases natin kanina. So, paano kapag ibang cases na? Paano natin magagamit itong tree diagram natin? So, tignan natin. Example number 3, let w be equal sa 2xz plus 3x squared y. Si x ay equal sa st plus rt. Si y equal sa 2r sin s. Si z ay equal sa t times e to the s. So, solve natin yung partial derivative ni w with respect kay r, with respect kay s, at saka with respect kay t. So, paano natin gagawin yon? So, gagamit muna tayo ng tree diagram. So, starting with w, si w ay function ni x, y, and z. So, we have these paths. Si x ay function ni r, s, at ni t. Si y, function siya ni r and ni s lang. Walang t, no? So, yan. And then si z, function lang siya ni s at ni t. Walang r. So, ito yung ating tree diagram. So, para makuha natin yung formula for partial derivative ni w with respect kay r, kukunin natin yung mga paths from w to r. So, itong pink na path, w to x to r. Yung green na path, w to y to r. And then dito wala, no? Walang from z. So, wala na tayong makukuha ang path dyan. So, dalawang terms lang yung meron tayo. Yung partial derivative ni w with respect sa x times partial derivative ni x with respect sa r. Plus yung sa green, partial derivative ni w with respect sa y times partial derivative ni y with respect sa r. So, ito na yan. So, yung partial derivative ni w with respect sa x ay 2z plus 6xy. Partial derivative ni x with respect sa r, we have t. Then, plus partial derivative ni w with respect sa y, we have 3x squared. times partial derivative naman ni y with respect sa r. So, constant yung sin s dito. So, we have 2 sin s. So, palitan lang natin yung x, y, and z gamit yung mga nandito sa taas. So, magiging ganito yung pink at magiging ganito yung green. So, pinalitan lang natin yung z, no? Ng te to the s. Yung x, pinalitan lang rin natin ito. Yung y, pinalitan lang rin natin dito. Okay? I hope naging klaro yan. So, for partial derivative ni w with respect sa s, we have these three paths from w to s. So, itong pink one, itong green one, at saka yung blue one. Okay? So, we have partial derivative ni w with respect sa x, ito yun, times partial derivative ni x with respect sa s, plus yung sa green part, partial derivative ni w with respect sa y, times partial derivative ni y with respect sa s, plus yung sa blue path, partial derivative ni w with respect sa z, times partial derivative ni z with respect kay s. So, ito na yung formula natin. So, apply lang natin partial derivative ni w with respect kay x. So, dalawang terms yung may x. So, dito ay 2z. Dito ay 6xy. So, 2z plus 6xy. And then times partial derivative ni x with respect kay s. So, we have t and t lang. So, yan. And then sa green path, so plus partial derivative ni w with respect kay y. So, sa first term, walang y. So, y lang to. So, 3x squared yung ikakopy natin. Yan. Times partial derivative ni y with respect kay s. So, yung 2r ay constant dito. Derivative ng sin s ay cosine s. So, we have 2r cosine s plus yung sa blue na path, partial derivative ni w with respect kay z. We have 2x here. Dito ay 0. So, 2x times partial derivative ni z with respect kay s. So, partial na to with respect kay s. So, we have te to the s. Yeah. Substitute na lang natin, no? Si z ay te to the s. Si x ay ito. Si y ay ito. So, pure substitution lang. Ito yung sa pink. So, substitute lang rin natin yung x, no? Magiging st plus rt. And lastly, yung sa blue. Kapalitan lang rin natin yung x. And this concludes yung partial derivative ni w with respect sa s. So, for partial derivative ni w with respect sa t, hahanapin lang natin yung paths from w to t. So, we have this pink one and this blue one. So, verify nyo, ito lang yung formula natin for partial derivative ni w with respect sa t.
I hope nakatulong sa inyo. So kung na-appreciate nyo itong discussion natin, don't forget to like and subscribe and share this to your friends. See you next time.